If you've done any kind of sports betting, but enantiomeric excess still seems confusing, this video should clear that right up. Hey there, ninjas. In a previous video, we looked at the calculation to go from an optical rotation to enantiomeric excess to a ratio of R to S enantiomers. In this video, we're not going to do any of those calculations. I'm going to show you how terms that you're likely familiar with in sports betting directly tell you how to interpret the enantiomeric excess. If you've even glanced at sports betting terms, you've likely seen an over-under and a spread. In generalities, you can think of the over-under as the sum total of points scored by both teams, and the spread is the margin of victory for the winning team. So if your favorite baseball team is playing tonight and the over-under is anticipated to be 20 runs, phew, high-scoring game, I think I'll take the under. And the spread, your favorite team is anticipated to win by 4 runs. Can you tell me what the anticipated final score is supposed to be? Pause the video, take a second, see if you can work through this, even if you're not very familiar with sports betting. If the total runs scored is supposed to be 20, and your favorite team is supposed to win by 4, what is the final outcome? There are lots of ways to win by 4 runs. It could be 4-0, 5-1, 6-2, and there are lots of ways to score 20 points. The final score could be 20-0, 19-1, 18-2. But there's only one outcome that satisfies both criteria. And that would be if your favorite team, let's call them the Reactors, gets a final score of 12, and the losing team, we'll call them the Separators, has a final score of 8. That would put the total number of points at 20 and the margin of victory at 4. Using enantiomeric excess to determine the ratio of enantiomers in a mixture follows this exact pattern. In chemistry terms, we always assume the over-under is 100%. The total mixture. And the key to unlocking this analogy is to treat the enantiomeric excess as the spread when the over-under is 100%. If you have a mixture of enantiomers such that the total solution is 100%, and you find out that the enantiomeric excess is 10% favoring S, what does that tell you about the ratio of R to S enantiomers in the mixture? Treat it exactly like the baseball analogy. If the over-under is supposed to be 100 and the spread is supposed to be 10, what is the final outcome that would satisfy both of these conditions? Since S is favored to win by 10%, we would expect S to be 55% and R to be 45%. That gives us a total of 100% and a spread of 10. Notice that it doesn't mean that the mixture is 10% S and 90% R. That's not what enantiomeric excess means. It means one side, the S side, is ahead by 10%. Let's do another example. If the total solution is 100% and the enantiomeric excess is 60% favoring R, pause the video, see if you can calculate the ratio of the two enantiomers. If you thought the answer was going to be 60-40, that would be incorrect. A 60-40 ratio would have an enantiomeric excess of 20%. In this case, if we need to add up to 100 and the R team needs to beat the S team by 60%, the only way to do that would be as if R ended up with 80% and S ended up with 20%. These add up to 100 with a spread of 60. One enantiomer exceeds the other by 60% while adding up to 100%. Notice how when you think it through using sports betting terms, it actually becomes quite intuitive. Let's do one more example. For our chemistry example, the sum total will of course be 100% of the mixture. And for this example, the enantiomeric excess will be 90% favoring S. It's 90% enantiomeric excess, we'd expect it to be pretty close to pure, but it's not going to be a 90-10 ratio. The only way for the two enantiomers to add up to 100% with a 90% spread would be if S was 95% of the mixture and if R was 5% of the mixture. These add up to 100 with a 90% spread. This is the nice part about enantiomeric excess. You can memorize all the calculations, but you don't have to. Sports betting makes the analogy quite simple. Keep up the great work, ninjas.
Thanks for watching. If you like what you saw today, maybe let your instructor know about these videos, or your friends at other schools. Check out some of these other videos and playlists, see what you like. As always, don't forget to like and subscribe.